Hello everyone, this is Bhaskar Chauhan from Gate Opener. Here I'm going to discuss about the question that I have given in the quiz section. You can see this question. This is very simple question from strength of material, and it is being asked about the finding out what is stresses at some point, certain points, right? So you can see the question is a hollow cylinder is attached to a wall while it is free and under a load. So you can see it is one side is fixed with the wall, other side is free with the uh, free, and you can see that there is some load is being applied, which is given as transverse load, but you can see as it is not able, we cannot able to visualize it from one end. So for that I have just given, just see this, I have given one more cross section so that you can understand this is transverse force. So this transverse force F is acting along the z axis and it is y axis. So you can clearly understand this is z axis and this is y axis. So this will be your y axis, this will be your z axis. Now the question is how we can find out what is the state of stress. So state of stress is what first we need to understand. State of stress is nothing but the the representation of stresses at a point. So at point, what, how many stresses are acting, what stresses are acting, that is nothing but the name is, that is the state of stress only. Okay, so you have to understand one thing, how we can determine it. So first we have to understand transverse load can generate what kind of stresses it can generate on any cross section. So they are asking, it's not at free end, at any cross section, random distance you can choose. So I'm taking this cross section, for example this is my cross section at certain distance from uh, for example x distance from free end. So you can see they are asking about at a point what stresses you are going to feel. So this thing is very important for you to understand, how we can see that what kind of effect this force will generate on a point. So this we can understand easily with the help of force transfer or force equivalent condition. So if I transfer this force to that cross section, what kind of things I'm going to have. So this force will generate some moment, that is F cross X, that is Fx, and another force will be generated here, this will be only transverse force. So I can represent this very easily. For example, this is the section at which I am representing. So if this is F force, I can apply F and F. So this is FF force acting here. So you can see this is nullified, right? So I'm transferring this force here. What equivalent force it can generate, that I'm going to tell you. So if this F force, I can see this F force and F force is at a distance x. So this is couple. So this couple will generate, and you can see this seems as a uh, from top it is clockwise. So I have to apply some anti-clockwise, what I can say, some anti-clockwise kind of uh, moment or anything. It's not about that what direction it is, but I can say clearly that one transverse force can generate one moment and another shear force. So this could be the most important thing or key of the question that you have to understand. You need to understand transverse force can generate one moment and one shear force or one transverse force. So that transverse force will generate another stresses or shear stresses, I can say it about. Or you can see that if I'm applying a transverse load on a beam, that can generate one stress, that is sigma b, another stress, shear stress, that is S into A into Y bar upon I into B is the width of the member, that you can understand. Now another thing, that bending stress is nothing but M by upon I. So what is Y and what is I? I is about neutral axis and Y is maximum Y if we are having, if we want to have maximum calculation. So as it is at the mid of some section, this is given A point is at mid of the point. So we need to understand what is bending stress in this. Just try to understand and figure it out. First of all, you have to understand one thing. If I'm applying this load will bend this beam like this. Can you imagine? So this beam will be bent like that. So if this beam is bending like that, what do you understand? The neutral axis is what? Neutral axis is nothing but about which the cross section is bending. So if I see, this is the only axis about which the cross section is tilting, right? So this cross section is tilting about which axis? Vertical axis. So that vertical axis will be nothing but our neutral axis. So I will be able to recognize what is neutral axis in this case. The neutral axis will be nothing but the y-axis itself. So if it is neutral axis, What is by representing? By is representing distance from neutral axis to the point. So if it is neutral axis, this will be lying on the same point. What you can understand, if the point is lying on the same axis, that means y max is going to be, or y is going to be 0. From here you can conclude sigma b is going to be 0. If bending stress is going to be 0, what is left now? You are going to have only shear stress. So shear stress will be non-zero because there is F force area. This y bar is different. This y bar is not from the neutral axis. This y bar is distance of shaded area. For example, this is your shaded area. So this distance is measured from from its centroid to neutral axis. That is different thing. So the shear stress distribution will be like that. So at neutral axis it will be maximum. So shear stress will be maximum, right? So that you can calculate. There is no issue with this. In this section I'm not going to discuss about how to calculate shear stress, but one thing you are sure, this question is up to the level of gate, or you can expect such questions from gate, the scenario. So this question I have picked for you to understand how to calculate shear stresses or stresses, normal stresses at a point. Okay, so this way you can conclude that the shear, only shear will be the option which will be correct. No bending is there, only bending is not possible, both bending and shear is not possible. Insufficient data, people can understand, may think about this, that free end, at the free end we will be having zero shear forces and all that. So that is not the answer. Okay, so insufficient data is not the answer. So only shear will be the correct answer in this case. Hope you understand the questions and the solution of the question that I have discussed here. Thanks for watching this session, guys. Have a nice day.